Okay, so we've labeled that f of x. A second function g is going to be talked about. And they're not showing us g, but they are going to give us the equation for g. Okay? So in part A, we're asked for the value of g of 0. And we have to show how we arrived at our answer. We're going to do it algebraically and graphically. So if we're asked to find g of 0 algebraically, that means we plug 0 into what function? The g function. If you want g of 0, plug 0 in for g. So I'm going to take this function, and I'm just going to write g of 0 equals f of 0 minus 3 plus 1. And then 0 minus 3 is obviously negative 3. So I need to find f of negative 3. No problem. I have the f graph. So take a minute to figure out the value of f of negative 3. Maggie, what do you think? I'm going to draw my x-axis a little more clearly too. So if you go negative 1, negative 2, negative 3, what's the y-coordinate that's going to go along on the function? Approximately? Do you see the point negative 1, negative 3, negative 2? That's not on the graph. Negative 3 what? Someone help her out. 1. Negative 3, 1 is right here. So f of negative 3 is 1. And then I have the plus 1 after the fact, and 1 plus 1 is 2. So g of 0 algebraically is 2. Graphically, if we want to get g of 0, we need to graph the g function. Yes? And we're going to graph the g function because it's the f function transformed how? What's the first transformation, Kelly? Very good. Right 3 units. So I'm going to take my critical points, 1, 2, 3. Move them all over 3 units. 2, 3. 1, 2, 3. 1, 2, 3. So there's my intermediate graph. When I shift it right 3 units. And then Lucy, how does it get shifted next? Not to the right, because right is a horizontal movement, and the horizontal is done. This plus 1 happens after the fact, right? So vertical. Vertical. Vertical means up or down? Up 1. Good. So all of those points are getting moved up 1. And here's my g of x graph. Okay, now I'm going to erase that middle one because it's just kind of clouding my picture. It's a little bit close to the g of x one, so you may not want to do it because you might erase part of what you need. But there's our g of x function. Now looking at that, what is g of 0? 2. Here's an x coordinate of 0, and so the y coordinate that goes along with it on the g graph is 2. Yes? So no matter which way we did it, graphically we got g of 0 equals 2. It's the same thing. So a lot of what we can do here can happen algebraically or graphically. If it can happen algebraically, I almost would recommend it because to take a time out to graph the graph we saw in the homework last night, it's not really a quick thing, especially when there's multiple transformations. So I would push the algebraic, but at the end of the day, I don't care, whatever gets you the right answer, unless it specifies that you have to do one way or another. Domain and range. Okay, so our domain of f of x, just again, domain is your x coordinate. So if I look at my f function, What's the lowest x coordinate I ever reach? 1, 2, -4 is correct. And the highest x coordinate I reach on the f function? 3. Is that right? So from -4 to 3. Hi, Mr. Tyler. How are you? I think it's in Tim Splinter's room. I do know we got an agenda, but I think it's in 166. Okay. If it's not, I'll try to find you. So -4 to 3. And our range of the f function, what's the lowest level it ever reaches? -2 all the way up until, I think that's a 4, right? 1, 2, 3, 4. So -2 is less than or equal to y is less than or equal to 4. Now again, it's going to ask us to come up with the domain and range for the g of x function. I know I have the graph of it right there and I could just look at it, but let's not. Let's pretend like we didn't do that work and do what we did on our homework last night. How do we get from the domain of this one to the domain of that one? We have to look at horizontal movement. What horizontal movement was there? Right 3 units. So what happens to these numbers when I shift them to the right 3 units? You add 3. So -4 becomes -1 is less than or equal to x is less than or equal to 6. So we're adding 3 onto those to move them to the right. And our vertical movement was shifting up 1, so what happens to our range values? Yep, -1, less than or equal to y, less than or equal to 5. They all increase because they've been moved up 1. And you can look at your graph of g of x and you can confirm that. Look at your domain. -1 is the furthest left it gets, all the way up until 6. And your range, the lowest it gets is -1, the highest it gets is 5. Does that make sense? Okay, so again, algebraically, graphically. Let's jump down to number 4. Okay. We're given a quadratic function. Now, it's gonna come up every different type of function we look at. I'm gonna give you the parent graph. Okay? That is the graph of that type of function before any transformations have taken place. And the parent graph of this is y equals x squared. So just think x squared. Now, this is in that family. You can see the squared there, but there have been some transformations that have taken place, correct? There's the -4. Is that happening within the x of the parent graph or outside of it? Within. So this is horizontal. It's a minus, so what kind of transformation? Shift right 4. Good. So the first, how has the simple quadratic been shifted? Right 4. And this -5, can we all agree that that's after and outside of the function? And so -5 means it has been shifted down 5. Okay? Does that make sense? Look at B. Given that the parent graph, y equals x squared, has a turning point at the origin 0, 0, where is that turning point going to be on f of x? Raise your hand when you think you know. Remember, everything, the domain, the range, the points, everything has been shifted right 4 and down 5. So what are the new coordinates of that 0, 0? Come on. I should have more than 7 or 8 of you. Give you another minute. Sam.
That'll be negative 4.
Raise your hand if you had a different idea. Okay. Kelly, what'd you think? 4, -5. Raise your hand if you thought something different than that. Okay. Let's see. Here's where it was 0, 0. I shifted everything right 4. 1, 2, 3, 4. And down 5. 1, 2, 3, 4, 5. So right 4, down 5. What are the coordinates of that point? 4, -5 is correct. Okay, so what happens with your paragraph, y equals x squared just looks like this. Okay, do you see how they're calling that the turning point? We also call it a vertex, right? The entire graph has been shifted right 4 and down 5. So the new turning point is there. So this is y equals x squared, and this is your f of x. Any questions on that? Okay. Jumping to exercise 2. We're going to do this a little bit more algebraically now. So, determine an equation for the linear function. We're dealing with this linear function. We're going to do 2 separate questions. And the first is going to be after a reflection in the x-axis. So think about flipping over, look up at the board. If you're flipping over the x-axis, is that a vertical or a horizontal reflection? Vertical. You're going from up to down. That's a vertical reflection. So when you are doing a vertical reflection, where does the negative sign go? Vertical reflection. Does the negative sign go outside or inside? If it's vertical, good, it goes outside. So that's going to be negative g of x. So I have to also negate the 5x minus 7. And when I simplify that, I'm going to get negative 5x plus 7. And that's the equation of the linear function after a reflection. Now watch how this works. I'm going to type both of these into my calculator. There's the first one. And the second graph I type in is this negative 5x plus 7 is supposed to be after a reflection in the x-axis. When I hit graph, here's my original line, and here's my line supposedly after a reflection in the x-axis. Does that look like it reflected over the x-axis? Very good. It did. Okay? Then we're going to do it after a reflection in the y-axis. So if you're reflecting it in the y-axis, where does the... First of all, here's the y-axis. Is it horizontal or vertical? Horizontal. So where does the negative go? Inside. So I'm going to do g of negative x. Which means I'm literally plugging in negative x to the g function. So I'm taking that 5x minus 7, but I'm plugging in a negative x in place of the x. Does that make sense? One is putting the negative out in front of the function, so I did that. One is plugging the negative into the function, so I did that. So when I simplify this, it's just going to be negative 5x minus 7. And I'm going to show you that as well. Oh, I forgot the negative. Negative 5x minus 7. So here's my original graph. And here's my graph after supposedly a reflection in the y-axis, a horizontal reflection. Did that happen? Yes. Okay? Any questions? All right. Let's look at exercise 3. Here's a parabola with an equation given. I think that's a minus 3x, in case that didn't copy well. Which of the following represents an equation after a reflection in the x-axis? So think, is that horizontal or vertical? Think about that on your own. Think about that on your own. And then once you decide if it's horizontal or vertical, decide where you should put that negative sign. Does it go outside or inside? Brock, what do you think? Does it go outside or inside? outside, because correct, it's a vertical reflection when you go over the x-axis. So to make that a vertical reflection, I just have to negate the f of x, which means on the right-hand side, I'm just negating this trinomial. And of course, you have to simplify that. You negate a trinomial by distributing the negative through. Negative 2x squared minus negative 3x is plus 3x, and minus positive 8 is minus 8. So the answer is option 2. Good. Make sense? Maybe, hopefully. Okay. We're going to jump to exercise 1 here. Jump all the way down here. Okay? Considering this quadratic function, that's f of x. They want us to write an equation for this g of x. And they're defining g of x by doubling f of x. Yes? So I literally have to do that, right? I'm going to take my f of x function and I'm going to double it. So 2 times f of x is going to be 2 times that trinomial, which is going to be 2x squared minus 8x minus 10. What is the transformation, if you had to describe it, that happened? Dilation, which direction? Vertical, because the times 2 is outside the function. Stretch or compression? Okay, so I'm going to compare the original function and then what supposedly is this after it's been stretched. 2x squared minus 8x minus 10. You ready for this? Here's our original, and here's our vertical stretch. Let me open up my window. Negative 20 to 20. Maybe we'll show it better. Here's our original, and here's our stretch. Which makes sense because where it was on the x-axis, both graphs still cross. But this vertex got stretched down, and these kind of legs here got stretched up. So it looks like it got vertically stretched. Does it not look like it got skinnier? So you see how a vertical stretch also kind of looks like a horizontal compression at times? Okay? And that's kind of part of why things are backwards. We don't need to go too much into that. So I say here to use the graphing calculator to graph the two, which I just did. Use the minimum feature to find the minimum of each. So you don't need to do this, just watch. Second trace, I'm looking for the minimum, yes? Scroll down to minimum. My cursor is currently on that first parabola, so I'm going to go to the left bound of the minimum, hit enter. I'm going to go to the right, scroll over to the right of the minimum, hit enter, and that minimum value is negative 9. So what do you think the minimum value of the other one's going to be? Who said that? Negative 18 is correct, because we doubled it, right? We stretched it by a factor of 2. So it jumped down to negative 18. We can confirm just by finding the minimum of this curve. See, my cursor is now over on that one. Left bound, enter. Scroll over, right bound, enter. Negative 18, because it's stretched by 2. Yes? Okay. We have probably just enough time to do these two. Here's our original point, negative 312. Where is that point going to move after this transformation? Think about that for a minute, and then I want you in your head to select 1, 2, 3, or 4. Okay, on the count of 3, you have to hold up your choice. 1, if you don't know, hold up a fist. 1, 2, 3. Uh-oh. It's 2. Was this transformation, when you multiply by 3, is that vertical or horizontal? Vertical. So what's the only coordinate that's affected? It's a vertical stretch. The x coordinates are not affected. So only the y coordinate got tripled. Negative 336 should be option 2. Nope, that goes back. Yes? That clear? Don't triple everything unless there was a vertical stretch and a horizontal stretch. Yes?
Is this one solution bigger?
This one, yes, do it on a substitute differently. Have a good day.